You were asked to sketch a number line and locate a number of points on the number line. In marking off the number line, we want to have the point 0, and we also want the number line to go far enough to the left and right that we can include all of our numbers. If I put 0 here, then since negative 32/5 is fairly easily seen to be the number that lies furthest to the left on the number line, we're going to want to have an interval between -6 and -7 to contain negative 32/5. Why between -6 and -7? Well, 30/5 would be 6. We can calculate that very easily. So 32/5 would be 6 between 6 and 7. So that negative 32/5 is between -6 and -7. To locate negative 32/5, we could divide the interval between -6 and -7 into 5 equal subintervals and locate negative 32/5 at the second of those to the left of -6. And I think everybody understood how and why that would be the case. Another number was -4. Clearly, well, that one's really easy to locate. 5/8. 5/8 is between 0 and 1. Everybody understood that pretty much immediately. And to locate it, we would divide this interval into 8 equal parts and locate the number at the 5th. Now that wouldn't work if you had a number like 47/593. You wouldn't be able to divide the interval into 593 equal subintervals, but that is theoretically what you would do to locate that fraction. Now, square root of 2. Square root of 2 leads us to some problems because most of us, I think all of us, know that that's an irrational number, and it can't be located even theoretically by subdividing an interval and picking one of the divisions at which to locate the result. The best we can do is approximate the square root of 2. Now this has been done without calculators and so forth. So to start, first we establish that the square root of 2 is certainly greater than 0 because 0 squared is less than 2. And it's certainly less than, say, 3 because 3 squared is 9, which is considerably greater than 2. As a matter of fact, 2 squared is 4, which is greater than 2, so that 2 is greater than the square root of 2. 1 squared is less than 2, so 1 is less than the square root of 2. 2 is greater than 2. 2 squared is greater than 2, so 2 is greater than the square root of 2, so the square root of 2 has to lie between 1 and 2. Well, we can think of dividing that interval into 10 equal subintervals, and I kind of did that. It's not real clear. You're not going to probably be able to see that on the video, but I can test the numbers 1.1, 1.2, etc. until I find one that's greater than the square root of 2 and one that's less than the square root of 2, and squeeze that down until those two numbers are no more than 1/10 of a unit apart. Okay, so how would I do that? Well, let's start with 1.1. Is 1.1 squared bigger than 2? If it is, then 1.1 is bigger than the square root of 2. Well, to square 1.1 without using a calculator, if you don't remember multiplication tables up to 20, or at least squares up to 20, you're going to have to find the square of that number. Now you can do that using the usual multiplication algorithm, but it's going to be much more profitable for you in this course to be able to square this number as a binomial. 1.1 means 1 plus 0.1, and we square that. Now there's a formula for squaring a binomial, and you can use that if you remember it. But really, I just want to go back to the distributive law. So what does it mean to square 1.1? It means to square 1 plus 0.1. 1 plus 0.1 multiplied by 1 plus 0.1 is going to then be the square of 1 plus 0.1. Now somebody mentioned that F thing, FOIL. Don't like that. It's a trick. It's not a law, and the distributive law really has to govern this. So multiplying this by this, I distribute over this plus sign, 1 times 1 plus 0.1 plus 0.1 multiplied by 1 plus 0.1. Then I distribute again. I distribute the 1 over this multiplication. I get 1 times 1 plus 1 times 0.1. And here I get then 0.1 times 1 and 0.1 times 0.1. Multiplying those out, I get 1 from 1 times 1, 1 times 0.1 is 0.1, 0.1 times 1 is 0.1, 0.1 times 0.1 is 0.01, and now I just add things up. I've got 2 0.1s which add up to a 0.2, 1 plus 0.2 plus 0.01 is 1.21, and there I have it in a way that doesn't rely on that F trick and doesn't go back to the multiplication algorithm. Again, it's kind of important and will be important later in the course to understand this particular way of squaring a number like 1.1. Okay, so I say now 1.1 squared is 1.21, which is less than 2. So to make it completely rigorous, I say, well then, since this squared is less than 2, then this is less than the square root of 2. And that uses familiar properties of inequalities that are reviewed in section 0.1, of course. Well, we can follow this and square 1.2 and then 1.3 and 1.4. We would find that 1.4 squared is less than 2, but very close. It's 1.96, and it's close to 2. And 1.5 squared is 2.25 if you work it out, and it's greater than 2. So we conclude that 1.4 is less than the square root of 2, 1.5 is bigger than the square root of 2. So we can write that 1.4 less than square root of 2 less than 1.5. Now we can do a reasonable job of locating the square root of 2. Having squared these numbers, we also see that 1.4 squared is much closer to 2 than 1.5 squared, so it's not going to be much different than 1.4 squared. We've already divided the interval between, not sure we've already done that. Okay, well, we did that. I did that down here. But we divide this interval into 10 equal parts and locate 0.2 just to the right of the fourth part. Okay. Now, questions get a little more challenging. What's halfway between 2/3 and 5/3? Well, a really good answer is, well, 2 and 5 is 7, and if you divide that by 2, you get 3.5. 3.5 is between 2 and 5. So that halfway between 2/3 and 5/3 is 3.5 Now that's not in the form of a rational number, but that's okay because we can divide that in our head pretty much. 3 goes into 3.5. It turns out it's 1.166 repeating, and we round that to approximately 1.17. So we can figure this out pretty easily without a calculator. In 1.17, well, we've divided this interval between 1 and 2 into 10 parts, so it's a little to the left of the second one of those parts, and we locate it rather easily. A little better idea would be to take 1/2 of 2/3 plus 5/3, which is going to be halfway between the two. And 2/3 and 5/3 adds up to 7/3. Half of that is 7/6, which is the same as 3.5 over 3, but that can be directly divided out. And it comes out approximately 1.17. Now, number between the square root of 7 and the square root of 12. Well, people pretty quickly got this. Said, well, you find, is there a number between 7 and 12 whose square root is a whole number? Yeah, 9. 9's between 7 and 12, so 7 is less than 9 is less than 12, so that the square root of 7 is going to be less than 3 is less than the square root of 12. Now, you could also reason it out, square root of 7 is between 2, whose square is 4, and 3, whose square is 9. Now, we immediately get to the 9 and the 3 by that, but square root of 7 is between 2 and 3. And the square root of 12, well, 12 is between the perfect square 9 and the perfect square 16. So the square root of 12 is between 3 and 4. 3, therefore, is greater than 7 and less than 12, so that, again, 3 is an answer to this question. Now, of course, 3 was one of the numbers that you were asked to locate on the number line, so you might have already located that by the time you get to this question. Okay, now all this speaks to the whole idea of inequalities. We've used some inequalities to express these. Everybody seems to have understood these inequalities. If you run into trouble on the problems that are going to be assigned, please let me know. But otherwise, I'm going to assume you're in pretty good shape with this, and I believe that is the case.